I'm James Dunlop. I'm a senior engineer with the Carbon Trust, and I'll be presenting today's webinar, which focuses on savings potential on small power and IT equipment. We've loosely titled it the final third, but I'll come on to that shortly. So in terms of the content, we're just going to go through a brief introduction, look at personal IT equipment, also server rooms, catering and staff equipment, and also energy performance standards, as well as the further support that's available through the Green Business Fund. So the aim of today's webinar is really to identify energy use beyond the standard areas of heating and lighting, which is common to many businesses, and also to understand how that can be managed and how the savings can be realized. We'll also talk about the performance standards for IT equipment and also other office equipment. And again, we'll talk further about the support available through the Green Business Fund. So energy use in this other section can be significant, and in some cases it can be as much as 30% of total energy consumption in an office-based environment. So it's important just to make sure that it is well managed and operating efficiently. So before I go into the webinar itself, just to give you a bit of background on the Carbon Trust, we are a not-for-profit organisation with a mission to accelerate to the move to a sustainable low-carbon economy. We provide support in a number of ways through advice like this to businesses, governments, and the public sector. Also through footprinting to measure and certify the environmental footprint of organizations, products and services. And also we help to develop and deploy low carbon technologies and solutions. So on the title of the webinar, the final third, essentially what we're talking about here is the area of energy use that comes from other areas, from small power and from IT equipment. So it varies from business to business, but understanding and managing that final portion of energy will pay dividends in the long run. So looking in more detail at a typical company, in this example here, we've looked at an older office, maybe built back in the 1980s, that sort of stage, might have a original heating system in place and would have older, less efficient lighting. So the proportion of energy use in this case can be seen in the chart. We're seeing a very high proportion of energy in kilowatt hour terms on heating, in around 64%. On lighting, again, it's high, it's in around 15%, and the remainder there is on the other energy use in terms of small power and IT. So again, it's loosely modelled around a typical office, 400 metres squared, with 30 staff using T8 fluorescent lighting. So the energy use in this scenario is in around 94,000 kilowatt hours, with a cost of about £5,900. So the other cost remains significant there. In this case, what we're seeing is a more modern office, maybe built in recent years after 2010. It would have more efficient gas heating, a newer system, also LED lighting. So in this scenario, heating is still a significant proportion of energy use. Lighting is less significant now that it's moved to LED, and the use on other systems is high in this case at in around 31%. Slightly reduced cost, given that there will have been improvements in IT equipment over those years. But you can see there, in this instance, we're talking about a third of energy use falling to small power and IT equipment. In this last example here, we're looking at a modern office again, in this case maybe built just within recent years, perhaps using an air source heat pump running off electricity to provide the heat source. In that scenario, you're essentially going to generate in around 3.5 units of heat for every 1 unit of electricity used. So it means that heating is a much smaller part of the pie. You can see there it's in around 33%, and with the overall consumption dropping elsewhere, lighting increases slightly to 15%, and we can see how significant then in this scenario that small power and IT equipment is, representing just over half of the energy use. Again, this is in kilowatt hour terms, so we're looking here at an all electric office that is using good standards of lighting and is using good standards of heating through the air source heat pump. Again, similar size for each of these scenarios, but just showing the relative proportion that you have on small power and on IT equipment. So looking then at the equipment itself, the first category we're going to look at is personal IT equipment. And I suppose in many ways, personal IT equipment is a mass market consumer product. Things like laptops, screens, that sort of equipment are used both in office environments and for personal use generally. Energy consumption is heavily regulated, which is a good thing, as we'll come on to. And step changes in technology along with this regulation have led to significant improvements in efficiency. And that applies just over the last few years, as well as over the last 10, 20 years. And a lot of that is driven by EU legislation called eco-design, and it provides an effective tool which tries to improve the energy efficiency of products in 2 ways. It tries to eliminate the least performing products from the market by setting a bar above which products have to perform, and it also supports innovation by promoting the better environmental performance of products. So what does that mean in practical terms? Well, if we look here at a chart taken from the current EU eco-design for personal IT equipment. So there's a lot of jargon and text around it, I suppose, there. But in essence, we're looking at 2 different types of system here. We're looking at a desktop computer, and we're also looking at a notebook computer. It's not really worth getting into too much of the detail on the categories. They're categorized A to D based on the actual specification of the computer themselves in terms of the number of processors they have, with the category D products having much more performance than the category A products. So D would be a high spec, high performance computer. A would be a lower spec, more basic computer with less processing power. But the takeaway here really is on the change in the figures. You can see here what the standard was back in 2014 and what it is now, or what it was in January 16. So looking at the category A computer, desktop computer, it was a minimum standard of 133 kilowatt hours per year back in 2014. That's moved to a minimum category in the latest regulations of 94. And the other takeaway from this as well is where the best performance has got to. So again, that was published, I think 2017, but the best performance at that stage was 33 kilowatt hours per year for that same type of computer. And again, you're seeing the differences there in each of the categories of desktop computer and also of notebook computer. And that isn't over that many years. I'm sure most of you will have computer systems that maybe date back prior to July 2014 and could well be operating at higher energy levels than are shown here on the chart. So that's been a good thing, obviously, for computer performance, and it means that whenever it comes to procurement of equipment, it's important just to make sure that your policies are driving purchases towards the best energy performance of equipment. And to say that the key point really is that big improvement in efficiency over recent years. Looking at the displays for computers, they're not currently covered under explicit eco-design figures like we saw in the previous chart, but there is plans to do the same sort of approach. So draft legislation was showing what best performance was back in December 2017. So this is looking at screens based on their diagonal viewing area. So you can see there, I've kept it in inches, hopefully it makes sense to most people, the sort of screen sizes that are involved there and the power performance in this case. So the power performance really is very good on these latest screens. You can see there in wattage terms for a 32-inch display, we're talking about 25 watts. The category on the right is for more bespoke ultra high definition screens, which be more common for TV purposes and the likes. But just looking out of interest at my own screen, the energy consumption figure was working out at around 138 watts. And again, that's way above these best performance standards. And again, it's a high quality screen that I don't think I've had for more than 2-3 years. So again, I think it's worth taking a look again at the procurement stage, at equipment, at the energy performance that's available out there, and make sure you're moving towards that best performance level. And I think in many cases, you'll be holding on to IT equipment for maybe 3-5 years or more. So you'll get the benefits from going to the best standard at this stage. Looking at other equipment, now this is taken from older information from CIBSE Guide F. They published a second edition in 2004 and a third edition in 2012. So the table there summarizes the changes from the second edition to the third edition. The key thing really is the change in energy performance in many cases there, rather than the actual figures, which you would hope would have been superseded over the last 6 years or so. So equipment like monitors are mentioned there, again towards the upper end of the scale from the previous chart, and you can see there the level of consumption that's involved in the more recent equipment. It also lists standby consumption for the same type of equipment. In terms of the figures for the second edition and the third edition. We'll come on to that in more detail on the next slide as well. But you can see here equipment like photocopiers can have significant consumption. Again, there's a huge variation in the range there. You can see in photocopiers, potentially there's an increase in many products there from the 2004 sort of era to the 2012 era. So again, the takeaway from this is really that it's important to look at what you're purchasing, at the energy performance of it, and not just its running performance, but also its standby consumption. And again, on standby power, this is something that's mentioned again in the eco-design standards. So essentially, since 2009, there's been a requirement for devices to switch into low power mode after a reasonable amount of time. And in 2013, the limit on that was less than half a watt in standby. But networked equipment had a different requirement, and often as new equipment came out, more and more of it was networked, and the level of standby power increased. So looking at a chart of how that picture has changed, the standby limit um, for a single device could have cost in around 39 pence per year back in 2013. Older equipment at the lower levels would have been more like £15, and equipment that was then networked but operating at poor standards could cost as much as £63 whilst operating offline. So I think, again, it comes down to procurement practices, looking towards the best standards, looking at the level of use whilst operating, and also the level of use in standby mode whenever you're making new purchases. And again, even with the 2017 figures, as we see on the right hand side of the graph there, you can see that the cost can be significant, again, even for recent equipment. So we've based that on a typical office. So we're really looking at an office that operates sort of 9 to 5, Monday to Friday, and could be wasting energy with equipment in standby outside of those hours. So again, the takeaway is really that the standby power does vary widely on equipment depending on the age, the type of specification, whether it's networked or not. And I suppose the easiest way to avoid any wastage from equipment, whether networked or not, would be to switch it off at the end of the working day, and to have in place good shutdown procedures at the end of the working day, and in particular going into the weekend. Okay, so moving away from personal equipment and localized equipment, and looking specifically at server rooms. Server rooms, again, have been tackled through legislation at the European level. Looking at that chart, it's graphing the amount of energy consumption in terawatt hours for servers across Europe, effectively, and the intervention that was indicated was brought into place and has trended the overall consumption downwards. It was a fairly specific area, but again, it's worth just looking at the specification of servers whenever it comes to making new purchases, looking in particular at their idle power limits. These are covered in guidance from EU eco-design again, and you can see there the sort of figures that are expected depending on the type of server in use. And again, there's much more on that on the EU eco-design website. In practical terms, however, aside from the equipment, often the issue is overcooling. Most server rooms will be fitted with air conditioning. Units typical to the ones shown there, quite often handheld controllers. And I suppose it's human nature. People want to make sure that the server room is operating at a cool enough temperature. They'll tend to set that temperature set point possibly as low as they can on that controller, down to maybe 16 degrees. That'll mean that the air conditioning has to work harder to achieve that. And what we would recommend really would be a much higher temperature to cool down to. A temperature of perhaps 23 degrees would be appropriate. And then the air conditioning equipment wouldn't be working as hard to meet that temperature requirement. And typically what you'll see is an increase in energy consumption of in around 8% for each 1 degree lower that the system is having to cool to. And this is backed up really by guidance for IT equipment and for data centers. In this case, we're taking this from American guidance from ASHRAE, the American Society of Heating, Refrigeration and Air Conditioning Engineers. Now, they're covering a lot of equipment here on this particular table. They're looking at enterprise level servers right down to personal computers and to workstations. So the main thing really to focus on is the recommended operating range, and they're suggesting that a comfortable range for all of this equipment is actually from 18 degrees C right up to 27 degrees C. So that means that if you are looking to provide cooling in your server room, it essentially doesn't need to be bringing it right down to the lowest levels. Temperatures of 23 degrees C could be adequate for the equipment. It's not going to have an impact on it, and it's going to avoid the energy costs associated with the air conditioning system. So another area of energy consumption, particularly in office-based environments, would be catering and staff equipment. So really thinking about this, I've split it into four main areas. Water heating, which is obviously important for hand washing, for kitchens, for areas like that. Hot water boilers for tea, coffee, to have that available on demand for staff. Kitchen equipment, in particular in larger offices, but most small offices will have at least a fridge, perhaps other bits and pieces of equipment as well, and also vending machines that would be in use. So looking at hot water in particular, under sink heating for hand wash is delivered in a number of ways, but one of the most effective that we would see would be the use of point of use water heaters like this. This is a small electric 2 kilowatt unit, well insulated with a small amount of storage. It's easy to control the temperature, and we would recommend that the hot water temperature would be in around 40 degrees C, with the flow rate kept to in around 4 litres a minute. Obviously, the higher the temperature that you're running your hot water system, and the greater the flow rate, would be the greater the energy that's going through the system. Whenever it comes to tea boilers, you can see there they have a reasonable power, and where you've got a larger office, it can be useful to have that on demand, but it would be useful just to keep that on timer to avoid energy wastage, so that it's time to switch off at the end of the working day, and in particular across the weekend, to avoid the system running continually. And whenever it comes to hot water provision, this is an image taken from a survey recently. You can see here that what does happen in older systems would be large hot water cylinders are in use. They're heated perhaps from the central boiler system or from electric immersion systems that they could store up to hundreds of litres of water at temperatures typically in around 60, 70 degrees, obviously, to avoid Legionella. And again, time control there can be poor, insulation can be poor, and the overall system can lead to quite high levels of loss. And I think that's really the benefit in having a smaller, local, well-controlled system, such as shown here on this slide. On fridges, again, I think as per personal IT equipment, a lot has happened in terms of technology improvements and improved performance due to legislation. So the chart shown here on this image is it's taken from American information. It's taken from the American Council for an Energy Efficient Economy. They've charted the refrigeration energy use over time since 1972, right up towards more recent periods. So you can see here that it's trended very much downwards, whilst the blue line at the top shows the size in cubic feet, which has had a slight trend upwards. And also you can see there the price in comparative terms over that time has trended downwards too. So it's a suppose it's a good picture overall in terms of the energy performance of equipment like that. The same would apply in Europe, and in Europe, as we're going to come on to later, we have labeling that you'll have seen in your domestic equipment, but would also equally well apply to equipment for commercial purchase, in particular for fridges and the likes. So in the image on the right there, you can see we're looking at an A++ rated refrigerator, which is operating at in around 280 kilowatt hours per annum. So it's giving you a good indication of what the energy use of that fridge will be over its lifetime, or over its operation during a given year as such. So essentially, with that 150 litre fridge, it's a under-counter fridge, something of that scale. It's, for comparison to the chart on the left, it's a 5.3 cubic feet equivalent in American terms. So basically, the energy performance that's been seen there would come out, I suppose, looking back at the chart, in around this level. So it's again, we've moved forward into 2018 sort of levels. So the trend has continued downwards in equipment, and the 238 is showing, you know, very good performance in comparison to that chart on the left. In terms of other equipment that you might have in an office environment, things like microwaves, again, it's worth looking at the performance, but they are relatively efficient. They're going to be operating for short periods of time, so probably less important than the likes of refrigeration that operates for much longer periods. Other simple things to consider, you know, if you're not using a water boiler, if you're just using a kettle, simple things like not overfilling it will just mean it's working that little bit less hard. Looking at dishwashers, again, the energy labeling will be important. It also will detail water consumption for products like that, so it's worth picking up before you make a purchase. And if it comes to larger offices, it's worth a closer review on your kitchen equipment. The likes of extract systems or catering gas can, I suppose, lead to energy wastage where they're not well controlled. If extract systems are running whenever cooking isn't taking place, or if the gas is used simply to heat the kitchen at the beginning of the working day, that can cause problems as well. So there's more information and guidance on these larger systems in our other webinars and guides. Vending machines, again, I suppose they're more prevalent in some offices, but typically the power rating can be high, as much as 500 watts, can cost over £2 a day to run. And I suppose where you've got products within them that don't require constant cooling, the vending machine can simply be switched off using a timer out of hours. That'll mean that it's not operating across the weekend, overnight, and periods like that, which will save you energy as well. Okay, so just come on now to energy performance standards. So we've talked already about the EU eco-design standards, and there is a lot of useful information on their website in terms of office equipment and equipment for use generally, both domestically and commercially. So they give a clear indication through their labeling scheme, as well as their, I suppose, the criteria we talked about earlier is aimed at manufacturers and people producing equipment to make sure that they're sitting within those performance levels, but they also give clear indication to consumers at the point of purchase through their labels, as we saw there for the fridge. There's also a similar scheme in the United States. It's known as the Energy Star scheme. It's backed by the US government, and again, looks to, I suppose, raise the bar in terms of energy performance. So you may see that on equipment purchased here in the UK, just due to the prevalence of American products. So looking back at our EU energy label in more detail, this would be a typical label for a fridge, as we saw on the previous slide. It gives the energy performance clearly displayed there in terms of the kilowatt hour per annum use, and it gives its relative performance to other products on the market. So I suppose everybody's moving towards the A's, the A plus, A plus plus figures. It also gives additional information on the product in terms of the capacity. You can see that example was a 155 litre capacity fridge with a 54 litre frozen compartment. Noise level, sorry, a slight typo there, is actually 38 dB rather than 34 there. And again, I suppose it helps compare suitable products. All of that will be available online for making purchases, as well as directly through stickers on the equipment in stores as well. So it's a useful way to quickly establish the energy performance of new products prior to purchase. On the US energy labels, it's a slightly different scheme. You can see there the Energy Star logo, which you probably will have seen in other products. So they have different criteria. They aim for the product categories to contribute to nationwide energy savings campaigns in the United States. They must meet the performance standards listed by energy efficiency, as well as by product performance. And they have a criteria that enhanced costs need to be recovered through savings in reasonable time. And again, to avoid just having one product available, that they need to make sure that efficiency gains can be achievable by a range of manufacturers. So in summary, I suppose on the technical content of today's presentation, it's useful to quantify and understand these areas of other energy use beyond heating and lighting systems. And I suppose good procurement practices are really the key. Looking at equipment whenever it comes to renewal, looking at the best standard of energy efficiency will pay dividends in the long run. It wouldn't necessarily be practical to replace high cost IT equipment simply for the energy saving, but whenever it does come to end of life or a need to replace, then it certainly would be worthwhile looking towards the energy performance standards and looking to procure the most efficient products possible at that time. That being said, there's simple, easy wins through good staff awareness, simply switching off equipment, making sure the likes of the photocopiers and equipment that sits on standby is switched off at the end of the working day, and in particular at the end of the working week, and also using timer controls, adjusting server room temperatures will give you good savings as well. Okay, so we'll just break for questions at this point, if any have come through.
Okay, James, we have a couple of questions here. So someone has asked, what would the potential savings be if the server was to be upgraded or replaced?
I suppose, again, looking at the server performance there, it would be down to the simple power performance figures there. We looked at the standby energy consumptions on the previous slide. So it depends what you were going from and to as such. But if you are able to pick up on the existing energy performance, either the power consumption in watts or perhaps kilowatt hour per year figures for the existing, and then compare that with the proposed. It should be fairly easy to work out. I think, again, it won't necessarily provide you a return on investment for the price of the server, but procuring the new server with the lowest energy consumption possible would be the best bet.
Okay, we have another one. Do you have any experience of utilizing a PC management system such as Night Watchman?
I have seen such systems, and I think they can be very effective, especially in larger organizations. Often the LAN-based connections to PCs and connections to monitors can be used to remotely shut down all PCs and equipment. It depends on the organization, but if you have, I suppose, similar times of working, and you don't have problems with having the systems shut down automatically, then that can be used to good effect.
Okay. Is there a good reference website to use for procurement standards? Is the ECA ETL leading edge for this type and other equipment?
The ETL lists are very good. They provide good information on a range of, I suppose, products that have energy as their primary factor. Lighting is well specified. Heating systems are well specified, and there is a whole host of information there on different product ranges. I think whenever it comes to IT equipment in particular, and I suppose more personal or domestic use equipment, the likes of the EU eco-design standards are giving a good indication as to where performance should be, but certainly it's worth checking the energy technology list first.
Okay. Can the sleep mode in a standard desktop PC make any substantial energy saving when away from the desk?
It does, yes, and that is specified by those EU eco design standards. Again, it is a piece of networked equipment, so there'll always be a background of energy use. It will make significant savings, though. It's just a matter of managing that, and I suppose making sure that people aren't relying fully just on the sleep mode, but are fully powering down the equipment when it's completely out of use, in particular at the end of the day.
Okay, and we have another one. If your equipment is on the ETL list, is reference information available to prove the energy consumption of this equipment? For example, some evidence to support the label?
Yeah, again, it'd be worth cross-referencing both in terms of the ETL and the labeling. In terms of the energy technology list, it tends to be it has set criteria for equipment, so that'll be laid out distinctly. And again, it'll just be worth checking what technology you're purchasing, if it's best described under the energy technology list, or if it's best described under the EU eco design standards.
Okay, I think that's all the questions we have for the moment.
Okay, no, that's great. Thanks, Susan. If there is anything further on those, feel free to email in, and we can pick up on it in more detail afterwards. But no, that's great. Thank you. And I just thought it'd be useful to pick up on the technical questions at this stage. There's an opportunity for further questions on the Green Business Fund itself just after this following short section, which I'm going to come on to now. Yes, so just going to talk further about Green Business Fund support. So as many of you are maybe aware, that the scheme has been operated by the Carbon Trust for a couple of years now through 2017, 2018. It provides a combination of advice, training, and also financial support towards energy efficiency products. And again, the fund or the scheme is essentially coming towards the end of its operation, but there is scope for the fund to expand both in the UK and potentially internationally using the same mechanisms that we've developed over the past couple of years. So in terms of eligibility, it's available to companies in England, Scotland and Wales. Specifically, it's aimed at SMEs, also applies to schools, sole traders, and also charities. And in terms of the definition of an SME, we're essentially looking at businesses which meet any of the two following criteria. So it has to be no more than 250 employees, turnover less than 25.9 million, and annual balance sheet not in excess of 12.9 million. The other criteria is that it can't be more than 25% owned by a non-SME, by a large organisation, effectively. So in terms of one of the strands of support we provide support through workshops. These are typically in around 2 hours long, and they help companies understand their energy consumption, identify no and low cost measures, and they're aimed at companies with less than 50 employees in this instance. You can see there that the upcoming dates around the country that we have planned for this month and into January next year. We also provide opportunity assessments, both remotely and through on-site surveys for larger companies with a larger energy spend. These are delivered by Carbon Trust engineers such as myself, and what we aim to do there is to focus on a few costed energy saving recommendations to help companies see what options are best to take forward. As well as that, whenever it comes to moving projects forward, we provide implementation advice, and we aim that at companies who have projects that they're ready to proceed with, who maybe want investment advice, maybe want to get a few different prices from our panel of accredited suppliers. We can then run a tender process and also evaluate the returns to make sure the best options are selected. We offer financial support. This is again coming close to the end of the funding, but at present we're able to offer 15% towards the total cost of energy saving equipment. There's an upper limit on that support of £5,000 and a lower limit of £750. So I think if you have a project ready to go now, there would still be potential to apply to the scheme, but unfortunately the funding for this is likely to run out in the coming weeks. And services beyond that include our virtual energy manager service, technical webinars such as this one, and also we have a range of publications for different technologies and for different sectors as well. We also provide an organizational carbon footprint calculator, which you can access online, input your fuel uses, and establish your carbon footprint. Okay, so that concludes today's webinar. If there's any questions on the Green Business Fund, I'm happy to answer them now. No, that's okay. Well, thanks very much for attending, and the webinar slides will be circulated afterwards. Thank you.